Hello all, so we'll be discussing conjugation and conjugate symmetry property. They are also termed as symmetric properties of Fourier transforms, DFTs. That is, uh, if x of n and x of k are DFT pairs, then let me highlight what to remember. Then x conjugate of n is given by has DFT x conjugate of minus k. And similarly, if minus n is there, that is x conjugate of minus n, then it will be x conjugate of plus k. So only difference is when positive sign is there, then negative sign will be there, conjugate will remain as it is. Similarly, when negative sign, then positive, conjugate will remain as it is. So we will be discussing different cases that first of all x of n is real, then real plus even, that is circularly even, then real plus circularly odd, then imaginary, and so on. Okay, but before moving towards the cases, let us prove this property. Though it is simple, but you can do it. I am doing the first part, I am proving this. Rest you can manage. So here is the proof. So how to proceed? Simple. What we will do? We will find DFT of x conjugate of n. So by definition, here x conjugate will appear and rest remains same. Now I am doing some modifications. This conjugate is being given to this whole term, that is conjugate. We can do this because this minus sign is being changed now. This minus sign becomes positive over here. So whole conjugate. Now what we will do? We want our original form, that is minus j 2 pi by n. So this minus sign and minus sign together will give us plus. So just bit modification just to prove it, and conjugation is as it is. Clear? Now this term can be written as this whole term, that is summation without conjugate, can be written as x of minus k, capital X of minus k, and n point DFT, and conjugate is as it is. Clear? Because if we have plus k, then it is nothing but our original x of k. But it is minus, so we are having minus k. So that's all we have proved. And further modification can be made, that it can be written as like this, n minus k, as per our property. So this is DFT of x star of n, and hence we proved. Simple. Now you can prove the next equation, that is this one. Okay, similar, by going to the similar steps. So it is very small, so I am proving that also. So first of all, we have to proceed it from IDFT. So IDFT of x star of k, IDFT of x star of k. So note that how to prove. Here we have proceeded through finding DFT of x conjugate, and we end up with this. Here we will be starting with this and will be ending up with this. Clear? So IDFT by definition of x conjugate is nothing but, here k will appear, in place of x star we will be having x star of k, in place of x of k we will be having x star of k, and rest is as it is, that is here plus will appear k into n. Here same thing, this conjugate minus same process is above. The whole is having conjugate. I hope it is visible. So this is bracket, whole is having conjugate. So again the same thing, that this minus j I am writing this as minus sign is given to k and conjugate is same as it is. Clear? So this term is nothing but x of minus n, this term, as per our definition, and conjugate is as it is. So it can be written as x star of minus n. Clear? So that's all for this. And similarly, using the property x star of n minus n. Clear? So that's all for this proof. Now let's move towards specific cases. So how we will proceed? So it's simple. When x of n is real, then what does it mean? It means that our x of n is same as x star of n, isn't it? Okay, so we will just apply this in this equation. So DFT of x of n is same as DFT of x star of n. So DFT of x of n is nothing but x of k. DFT of x star of n is nothing but x conjugate of minus k n. Clear? And it can be written as this also, n minus k, as per our property. And similarly, x conjugate of k, taking the conjugate of this only, we will get the conjugate of conjugate will be as it is, and it can be further modified as, if you want, then like this. Clear? So what we can say, it proves a very important point, that let me write through a different color. Sorry. So what does it mean? It means that the conjugation is giving the conjugate of x of k is x star of minus k. It means that this is conjugate symmetric. This means the DFT, conjugate symmetric. This means that the even sequence has DFT conjugate symmetry. The conclusion. Clear? Now moving towards case number 2. So for case number 2, we have real plus circularly even. So x of n is real. This is case 2. X of n is real, so x of n is same as x star of n. Since it is real, so imaginary part is 0. But it is said that it is circularly even also. That is, x of n is same as x of minus n also. Okay, so simply what we will do now, taking DFT of both the sides, DFT of x of n equals to DFT of x star of n equals to DFT of x of minus n. So just writing this as x of k, we know DFT of x star of n, it is nothing but this x star of minus k. So it can be written as x star of minus k, and the same can be written as x of minus k, because this is x star of n has DFT this, but DFT of x of minus n is x of k as per our circular time reversal property. So that's it. So what's the conclusion? Conclusion is that x star of minus k is same as x of k, and also it is same as x of minus k. It means that if we have sequence real plus even, that is real plus even, then its DFT is real plus even only. this indicates even and these two are same, it indicates it is real. Clear? So this is real plus even is real plus even. Now real and circularly odd. So let's move towards case number 3, that is xn is real and circularly odd. So this is case 3. So when xn is real, we have this and it is odd, it implies it is minus times of x of minus n. Clear? This is x of minus n. So just again taking DFT on both the sides. So DFT of x of n, similarly DFT of x of conjugate of n, and similarly DFT of minus x of minus n. It is nothing but x of k. It is nothing but x star of minus k, and it is nothing but minus will be outside, and it is x of minus k n. Clear? Same as time reversal property, it is circular time reversal property. So what does it implies? It implies that this implies the if we have real plus odd sequence, then what we are getting? We are getting imaginary plus odd. That is, odd term is changing our real to imaginary. Okay, so why it is the conclusion that real plus odd will be imaginary plus odd? From this, that is, if x of k equals to x star of minus k of n, then it can be written as one more step, x of k equals to, I am writing this as x star of n minus k, and it is minus x of n minus k. So this term and this term, or we can say that this x of k is same as minus x of minus n, which tells our sequence is odd, whereas x star of minus k is minus times of this x star of k, which indicates that our resultant will be odd. Clear? So let's move towards next. I hope it is clear. We can prove that it is imaginary from this also. X star of n minus k is minus times of x of n minus k. Clear? Now case 4, that is xn is imaginary. So this is case 4. So when xn is imaginary, clearly xn is same as minus x conjugate of n. So taking DFTs both the side. So DFT of x of n equals to DFT of minus x star of n. So it is x of k equals minus, what is DFT of x star of minus is outside, it is x star of minus k n. So it can be written as minus x of n minus k. Clear? So if we take one more conjugate, then we are left with minus x of minus k equals to minus of x minus x of n minus k. What does it mean? It means that if xn is imaginary, then x star of k is same as minus of x of minus k. And what does it mean? It means that it is conjugate asymmetry. So we are writing CAS, that is conjugate asymmetry. So what's the conclusion? Conclusion is that if xn is imaginary, then its DFT is conjugate asymmetric. If it is if it is imaginary, then it is conjugate asymmetric, and if it is real, the case number 1, then it is conjugate symmetry. This is conjugate antisymmetry, or we can say conjugate asymmetry. Clear? Now one more, imaginary plus even, that is circularly even. So what does it mean? Imaginary means this thing is clear, and even means xn is same as x of minus n. Just taking DFTs on both the sides. So I'm writing directly, this is x of k, this is minus x star of minus k n, and this is x of minus k. Clear? So what's the conclusion? We can directly draw the conclusion, or we can take conjugate again. No, we can directly tell. It is x star of minus k, it is same as x of k, and x of k is same as x of minus k. First of all, these two terms means our DFT is even. What about this imaginary or real? This can be seen from this too. That is x star of minus k is minus times. Then it means it is imaginary. So that's all.